Hey everybody, welcome back to another map of the day. And the map we're looking at right now is called Frozen Fortress. So the way the map works is that teammates are all together within the same shared set of walls. There are gates to the front of the walls, but not to the back. So there's a limited amount of resources and space for players to use in their fortress, and they can access the rest of the map to the back if they were to delete the walls and walk out. But if you'll notice, these walls are on top of ice terrain, so if you ever happen to delete the wall, you can't re-wall, and you can't wall behind it either. So that would go similarly if you were to breach the opponent's walls. They would not be able to rebuild the wall or wall behind it. So this makes the map a bit more aggressive and unpredictable than your normal fortress style map. So we're going to be recreating this map. So let's get started. So before we get to the map itself, we're going to go through a little mini lesson on ice terrains because there are different types and they can be a bit confusing. So there are 3 different types of ice terrains. So we have terrain 35, terrain 26, and we have terrain 37. So we'll start off first with terrain 35, and terrain 35 is just generic ice. If you just put ice in a random map, that's what terrain 35 is going to be. And the properties of terrain 35 are as follows. So normal buildings cannot be placed on it. Same goes for walls. And then if we want to look at some other units, we can try boars. They can be placed. Deers cannot. And that's about it, I think. And now we go over to terrain 26, which is quite similar in the sense that you can't put deers, you can put boars. Normal buildings cannot be placed on it, nor can walls. But unlike terrain 35, terrain 26 is navigable. So if we have a water unit, so fishing ship, that can be placed on terrain 26, whereas it cannot be placed on terrain 35. And interestingly, you can place a dock anywhere on terrain 26 without it needing to border any water terrains. And that also goes with all fish types also. So normal deep sea fish can be put on terrain 26, as can shorefish, without needing to border any water terrain. And now we get to terrain 37, which is slightly different. So terrain 37 is basically a beach terrain. So if we go over to buildings here, you can see that normal buildings cannot be placed on it, but walls are not restricted to be placed on any beach terrain, so this terrain is wallable. If we go over to other units, we can see water units can traverse across terrain 37. But if we go to docks, docks cannot be placed on terrain 37 without bordering water. And then when we want to talk about fish, we can see that deep sea fish such as dorado, perch, salmon, snapper, tuna cannot be placed on terrain 37, nor can shorefish. But if we want to go up over here, there are other types of fish, what the game refers to as ocean fish, which can be placed on terrain 37, and that includes marlins and dolphins. So, and of course, with any of the 3 ice terrains, none of them will be restricted to a regular land unit from traversing across it, which includes all of the buildable units on the land that could possibly be made by players. So those are some of the properties of the different ice terrains, and when we're making our map, it's going to be important to keep these in mind because we're going to be using some of these terrains. And when we're making our map, well, we should know that it can be possible to get past some of these terrain restrictions with objects by using either RMS effects and or placeholders, but it's important to know what the properties of terrains are so we know how to use them and how they behave. So with that out of the way, let's go to the test script and start making our map. That's going to start with the player setup section. And in this case, since we want teammates to be close together, we will say grouped by team is our player setup. And then we will go over to the land generation section next. So the base terrain of the map is going to be just generic ice, which is terrain 35. And we'll create the player lands next. So for the player lands, I'll try to have the terrain type is going to be ice as well. And it's going to be, the base elevation is going to be above the rest of the map, which is going to differentiate it from the other ice, which is the base terrain. And for the area of the land, we don't want a whole lot of the area to be taken up by number of tiles or land percent. We want our bases to be a relatively consistent square shape, so we want most of the player base to be defined by the base size rather than land percent. So we'll set the number of tiles to 0 for now, and we can adjust it as we need to, and set the base size to be relatively high, which is going to be 20. We will set zone by team, and we'll add a circle radius also, so will be 35% of the map's length away from the center and without any variance. So since we added a base elevation here, we of course need an elevation generation section. And let's see what we have for us right now. We'll test a team game situation, so it'll be pretty clear where the different teams are. So right off the bat, we can see that the base terrain of our map is ice, but we really can't tell where the player lands happen to be. Based on what we've done so far, we would expect to be able to differentiate the player lands based on this higher elevation that it's supposed to generate at. But that's one of the limitations of using ice terrains, is that you cannot apply a base elevation to an ice terrain, and that goes also for a water terrain. We can see we have the player lands, but they are not elevated. So I don't know why that's the case, but that's just the way it is. So instead of using ice as the terrain type for our player lands, we're just going to use some placeholder which we can replace in later. So we'll just call it dirt 3 for now, and base elevation is going to work on a normal ground terrain, just like this, and we can cover it up later as we need. So right off the bat, we can see the area that the player lands are taking up based on the different terrain and the elevation here. So when we set up our player lands to have no tiles, that just basically leaves the area to be taken up by the base size. And we can see the effect of that here is that not all the player lands are necessarily going to touch every single time. We have a bit of overlap here, but there is still some separation here, which is not really ideal. So we're going to add a few more tiles to the player lands. So we'll just try this right away and just say we'll add 300 tiles to the player lands. So let's generate the next map, and let's see, and we can see what happened is that the player lands look a bit more full since we added some tiles, but let's keep on generating. And we can notice a couple of things here. So there's always seeming to be like one or two lands that don't seem to have tiles added to them. See, we can see this land over here got rounded a bit because of the amount of tiles, but this land over here seems very straight, as if no extra tiles were added. So that's very straight over here. And we can see correspondingly a land over here that was rounded because extra tiles were added, whereas this land over here doesn't look like anything was added since it still looks very straight. And that seems to be a reoccurring theme, since this land looks very straight, whereas this land looks very, clunky. And this is kind of a legacy bug that has existed for a while, which produces this kind of effect where different lands can have different numbers of tiles. And the definitive edition produced a command to try and fix that issue, and that command is behavior version 1. So this is supposed to fix that issue and make sure every player land is going to have the same number of tiles in this case. But if we do that, we can see right away that it basically put it back to the way we had in the beginning, where everything is just a square and no tiles were added. And that's because the default behavior, basically the way we have it now, it will add the number of tiles onto the area that's already comprised by the base size. So if we were to do a little math here, so the number of tiles that's comprised by the base size is going to be 20 times 2 plus 1. So that's going to be the length of the square. And then times another 41 would give us 1681 tiles. So it would add those 300 to that 1681 to get the tiles that we saw. Behavior version 1 works slightly differently in the sense that tiles will only be added to the land if the total tiles exceeds the area that's already taken up by the base size. So if we were to put this at about 1600, we should still be at the point where we're not seeing any extra tiles. But if we increase that to be slightly higher, 1850 tiles, that puts it above the area that's comprised by the base size. And that does a bit better job for us here. It looks like all the player lands seem to be nice and rounded, and we're no longer running into a situation where one among the many lands is unaffected by the increase in tiles. And then also, just for good measure, I'll put a clumping factor of 20 on these player lands so that they'll stay as round as possible. So we can see the effect of that here is now when we keep generating our map, the teams will always be connected because we just added a few more tiles to the outside of the base. And that works consistently for all the players since we used behavior version 1. So if we take a look at what we have now, we have the majority of our map just looks like ice, and the only elevation is where the players are. And if I wanted to put some hills along the rest of the map to make it a bit more interesting, I would prefer to have those hills spawn slightly a bit farther away from the player lands, so we don't get any interruptions there. And by that, I basically mean I would prefer the terrain over here to be a different terrain than the slope of the hill here, so that we can differentiate that when we create hills. And we can do that if we create another neutral land in the middle. So you create land. Terrain type is going to be snow. Land percent is going to be 100. Land position is going to be 50-50. And then in addition to that, we will say spacing to, well, no, it's not, other zone avoidance distance will be 5, and we'll put that same thing on the player lands up here, so that when we generate our map, we can see that now the majority of the outside terrain is now a different terrain than the slope of the player lands. So now we can more easily differentiate the place where we want to create hills. So if we want to put hills on our map, we can put it on the snow. So hills here. And now we have some hills in the middle of the map here to make it a bit more interesting while staying a sufficient distance away from the player lands to not obstruct anything over here. So now let's move on to the terrain section of the map. So the first thing we'll do is create terrain snow on top of ice. Land percent is going to be 100, and we'll put it at height limits 0, 0. So let's just increase the number of clumps. Okay, so now we have this. So at this point, I want to start doing the terrains on top of the player lands here. So wherever this ice terrain starts to begin is where I want the walls to be. So whatever the next layer is past this ice, I want that to be a differentiable terrain so we can target that to place walls later on. So the way we're going to go about doing that, I'm going to put grass on top of dirt 3, and we'll say spacing to other terrain types is 1. So this little layer, which currently is dirt 3, is going to end up being where we're going to place the walls later on. And now we want one layer to be behind this to sandwich the walls in between at least one tile width of ice. So in addition to this, we will say we want to place road 2 on top of grass. So we have one tile width of dirt 3, one tile width of grass, and we want to fill that grass in with normal ice terrain. So we will do that, create normal ice on top of grass. So now we can see the slope of our hill is ice, and now we have one tile width of ice that's separating wherever the walls are going to be from the rest of the player lands, so that players will not be able to wall behind over here. And then we wanted this terrain for the walls to be differentiable, but we also want it to blend in nicely, so we're going to use another ice terrain, which is going to be terrain 26. So going to put the saleable ice on the dirt 3. So now it blends in nicely, and we know we have two different terrains here, and it'll be easy to see if we try to place a water unit. So Where we have the normal ice, we can't place the water unit, but with this small strip of saleable ice, we can see that we have a differentiable terrain, and we can target that later on to place walls. So next step, we're going to create the forest on top of the player lands. So I want to do that one team at a time. So I will normal road on top of road 2. Land percent 100, not specifying the number of clumps because we only want one. So now one player's land is road 2 and the other one is road. So we can, after this point, create snow forest on top of road 2, land percent 2, number of clumps 4, set scale by groups, set void player start areas, and we'll say also spacing to other terrain types can be 1, and we'll do the same thing with normal road. So now at this point we have an equal amount of wood on this set of player lands as we have on this set of player lands. And now we can cover the road, back up with road 2, and then we'll fill in player lands with the majority of ground terrain. So we'll say snow on top of road 2, set avoid player start areas. So that would end up looking, what did I do? So that would end up looking like this. And then to top it off, we'll just say this again, create snow on road 2, but instead of setting avoid player start areas, we'll do terrain mask 2. Which just leaves a nice looking area around where the player is going to start, which is still considered snow, and the road is just masked on top of it. So after that, we can create whatever forest we want for the rest of the map. So we'll create snow forest on snow. Actually, we'll do that, well, we should do that before we create the snow on the player lands. We'll have 12%, 16 clumps, and we'll spacing of the terrain types is going to be 2 in this case. So now we have the rest of the forests, which is outside of the player lands, like that. And then finally, to wrap up the terrain section, we'll just have a couple of decorative things. So we'll just layer some grass and some gravel on top of the snow. And then one more thing is that we're going to create some DLC water 5 on top of snow. And notably, that's before we covered up the player lands with snow, so that this decorative water will only show up over here on the outside, so it's not going to spawn on top of the player lands over here. So that's looking pretty nice. And now we need to think about the fact that we want to have gates for the players, which are going to be towards the front, and not allow gates towards the back. And in order to place gates, we're going to need yet another differentiable terrain to know where to place those later on. So we've already used terrain 35 and 26 for ice terrains. So the last one we'll use is going to be icy shore, which is terrain 37. So basically what this connection statement is going to do is going to draw connections between the players and replace all of the saleable ice, which is 26, with icy shore, which is 37. it's going to be a reasonable thickness. And if we want to take a look at whether or not that actually worked, we can go over to buildings. We should be able to see some sections in which it's now wallable because we're using terrain 37 instead of terrain 26. So we can see where those connections have put the different terrain in the front, but if we go over to the back, we can see that that terrain is not going to be existing because all the connections are made between the players, which would never go towards the back. So to begin the objects section, I will paste in the basic player objects so we can use that as a starting point for the next point at which we create the walls, which is going to be a bit tricky. So first we can start off with what we know is that we have terrain 26, which is sandwiched in between two layers of ice. And we want to target that area to place walls. So if we get a placeholder object, which is on grid, we'll use $278, which is a dead fish trap. So after this is done, we will create object. Many of those objects, set place for every player. We'll say max distance to players is going to be 25. The base size we had specified was 20, and since we added a couple tiles to that, we'll go as high as 25 for the max distance. And we'll say second object will be wall. Since we can't normally place walls on top of terrain 26, this on-grid placeholder is going to be needed. And we should probably specify the terrain to place on. Okay, so now we can see we are at the point where we have enough walls on the outside surrounding the player base, but we still need to figure out how we need to get gates in here, because even though we have terrain 37 over here, which we can technically build gates on top of, it's going to be really difficult in this case to make those gates player controlled because we still have this one layer of normal ice separating this terrain from players, so we shouldn't be able to place it there. And then getting a placeholder for a gate is kind of annoying also because there are very few objects in the game which are the same size as a gate. A gate is a very weird shape. It's 1x4 tiles, whereas most other objects are basically squares. So in order to achieve what we need to, we're going to have to be a little clever with the way we use a placeholder to get the gate in the right position. So if we look at the object list over here, we can see that in addition to normal gates over here, we have these things which are called city gates. So these are the exact same size as normal gates, except they cannot be built by players. They're only a scenario object, so this will be a nice placeholder to use for our normal gates. So in our map, we'll be needing a couple of constants. So we'll have the gates that we will end up using are gate 1 and gate 2. These are the constants, and those are going to represent one gate going down, one gate going up. We're not going to include diagonal gates here. And then the city gates constants are representing the corresponding gates going up and going down, which we will use as the placeholder. So in order to allow these city gates to be placed past this one layer of ice terrain, we have to change its terrain properties. So we will do that with effect amount set attribute citygate 1 AGTR terrain ID, and setting it to 0 will allow it to be placed anywhere. And we will do the same thing with citygate number 2. And what we'll do with those gates is we will create those in the object section. We'll create them before we create the walls at first, so the gates will have a bit more freedom to be placed. So we'll create object citygate 1. Number of objects is going to be very many. We'll say temp min distance temp min distance replacement will be 7. We will say set place for every player. We'll say max distance to players will be 25. And we'll do the same thing with citygate number 2. So basically, actually we'll have a terrain to place on icy shore. So basically what this is going to do, it's going to find as many places along the icy shore, which we have here, to place as many gates as it can while staying a certain distance apart. So, as we can see, we've been able to place some gates, but they're not necessarily spawning in the correct orientation. We can see that the gate that's going down here is really not supposed to be here. It's not facing the right way. So we're going to need to find a way to get the correct gates to spawn in the correct orientation so that, for example, a gate going down here won't spawn in a place where a sideways gate like this is supposed to spawn. So to achieve this, we're going to need the help of a unit, which is pretty special. That object is a terrain blocker, which is object 1613. So basically what a terrain blocker does is it just takes up one tile of space and prevents any object from being placed on that tile after it. The terrain blocker has an HP of 0, so it goes away as soon as the game starts. But for the purposes of creating the map, this is going to prevent the gates from spawning in the wrong location. So at the very beginning of the object section, what we'll do first, just comment out this for now, we will first create object on grid number of objects so scaling to map size. We will say terrain to place on the icy shore, and we'll try and indicate that with second object flag A. So now we have a bunch of flag A objects, which are generating everywhere on the icy shore over here. So that's indicating where those are. And then what we'll do next is we'll create an actor area around these objects. So actor area is going to be number 1. Actor area radius is going to be 1 also. And so we will say create terrain blocker on normal ice. Actor area to place in is going to be 1, and the second object is going to be flag B. So basically, what we have done is we've created these terrain blockers, which are going to prevent the gates from spawning on these tiles here. So basically what that does is if we happen to have a gate that wanted to spawn in the incorrect position, for example over here, it would no longer be able to do that because these white flags are representing tiles in which it cannot spawn. So the only gate that would be able to correctly go in the right place would be the one that's supposed to be there. And if we uncomment the rest of the script here, we should be able to see that the gates should be in the proper spot. See, now that's more like it. So the terrain blockers are preventing a gate that would be going this way from spawning here because these tiles are basically blocked. So that's helping us out quite well. And then for the remaining areas over here, which are not occupied by a gate, we can place some more walls on top of that. So in addition to the walls that we're placing on the ice sail, we'll put it on icy shore also. And we will get rid of these flag indicators. So that's looking pretty nice. And now, right now we have these city gates in here. And so if we want to change them into normal gates, what we can do is second object gate 1 for city gate 1, and then gate 2 for city gate 2. For some reason it doesn't work super well when you try and upgrade city gate into gate. So this is basically the next best thing. And to make sure that the city gate goes away at the start of the game, we will set attribute city gate hit points to 0, and then for city gate 2 also. So now for these RMS effects to actually take effect, we should be testing this in a standard game and not the editor. So we'll go do that and see what we have left to do. So when we start the game, we can see that the city gate is basically dying right away since we set its HP to 0, but the rubble is still left over. And then also notice we have these little weird situations, and we have the different players' walls on each team overlapping. And we didn't really see that in the editor, but it's seeming to be a problem now that we're in a standard game. So we used object 278 in order to use that as a placeholder for the walls. And even though object 278 can't be placed on top of solid objects such as walls, other objects can be placed on top of it. So at the point in time where we place object 278 per player, there's nothing stopping the player from the other team to have their walls spawning on top of the walls from the first player. So in order to fix that issue, we will have to go and do some little tricks with actor areas. So if we were to put an actor area around the first set of walls, we'll say actor area 2, actor area radius is 0, and if we say avoid actor area 2, this is basically the only way to get objects created per player in the same command to avoid each other. So if we were to notice way back here where we have overlapping walls, let's see if that actor area trick fixed it for us. And we can see indeed that actor area trick made it so the walls are no longer overlapping in the back over here. but we still have this issue with the walls of one player overlapping with the gate of another player. So we could put an actor area around the gate if we wanted to also. And the actor area around the gate is a bit awkward because usually objects have a nice square in the middle to represent where the actor area radius is going to start from. But for a gate, it's a little bit different. It's actually one of the, since the gate is 4 tiles, it's actually one of the ones in the middle. Doesn't necessarily matter which one. So for the gates, we'll actually call this actor area 3 and avoid actor area 3 because we're going to put actor area 2 on top of the gates with the radius of 1. And actor area, and for the walls, in addition to avoiding actor area 3, it's going to avoid actor area 2 also. And that'll be the same thing for these other walls that are being placed on Icy Shore. Okay, so that looks a bit better now that the walls are no longer overlapping on top of the gates. So if we look around here, we can see that there are, in some instances, that actor area that's preventing the walls from spawning is actually leaving a gap in the wall. If we were to look at very closely over here, we have the wall over here, the gate over here, and if we take a look, it looks pretty apparent that the actor area is basically acting around this tile right here, and if we drew a radius 1 unit around that, it's basically preventing the wall from spawning in this tile right here. So that's a small bit of a problem, but for those very rare situations, what we're going to do is we're just going to cover those up with generic rock objects. So if we say create object rock, number of objects very many, we'll set scaling to map size, terrain to place on, we'll have one for ice sailable, and then we'll have another one for icy shore. So it's going to cover up those little last bits of missing tiles. So we can see where previously we saw that that tile was basically empty, we now filled that in with a rock. That plugs the remaining holes in the players. It can lead to some minor obstructions sometimes, but it's usually not that big of a deal. See, that's not big of a deal, and this gate still looks like it's passable. And even if it isn't, there are plenty of other gates too. So I guess the next thing we can do is, so if we take a look around, we can see that we had inadvertently created a bunch of rocks on the icy shore over here, that we placed them over here also. So that's a minor inconvenience, but we can get rid of that. So what we will do is we'll grab, instead of an on-grid object, we'll grab an off-grid, which is going to be 647. That's going to be useful later on because 647 can be placed on top of existing objects, whereas 278 cannot. So before we place the rocks on the icy shore, we'll just create object off-grid. DLC water 5, and we will say actor area will be, where did we leave off? 4. Actor area radius, say 2. And we'll say for the rocks on the icy shore, we will avoid actor area 4. And then while we're at it, we will get rid of the rubble on the city gates. So to do that, we will set the ATTR storage value of the dead object to 0 and 0 also for both of those city gates, which basically sets their corpse decay time to 0, so after that animation is done, the dead unit will just disappear. So if we happen to be looking at the gates within the first 10 seconds, the animation will still be there, but since we set that corpse decay time to 0, the rubble goes away instantly. And since we told the rocks to avoid actor area, which was around the water, they don't spawn there anymore. We still have these fish traps, but we can address that. So in a similar way, setting the storage value of the dead gates, we can set the storage value of the on-grid objects to be 0, so they'll go away as soon as the game starts. So now we don't have those weird looking fish trap things which are spawning on top of the shore over there. And then lastly, if we want to have some towers on our map, we would want to place them with respect to the walls, very close to the walls. So we can use another actor area for that. But since we already have an actor area around the walls, which is actor area 3, we can't have another actor area of a different radius at the same spot. So we'll say that both sets of walls are comprising actor area 3. And what we'll do next is we'll create another set of off-grid objects, which will be set place for every player. And we will say actor area to place in will be number 3. So basically these off-grid objects can be placed on top of the walls, which will be right on top of the wall since that actor area radius is 0. And then actor area 5 will be with radius 2, because if we look, radius 1 would put it right on top of this ice, so actor area radius 2 is the first buildable tile which we can have a tower on. So what we will do is we will create object watch tower, number of objects 100. We will say set place for every player. We'll say actor area to place in will be 5. Temp min distance replacement 12. And for good measure, we'll put another actor area around the watchtower, actor area 6, radius 6. And we'll say avoid actor area 6 to keep the individual players' watchtowers away from each other. So I think that should be good. So now we have towers on our map every so often. So that's looking pretty nice. So at this point, the fortress aspect of this map is pretty much done. So we'll just paste in the other objects in the objects section, and is the other resources on the map, the golden stone that's going to be inside the player walls, some of the food resources, and then some of the extra objects that are going to be spawning outside. So that's going to complete the objects section for us here. So at this point, the map looks like it's done, but we have to ask ourselves whether it's actually done. And most importantly, we're going to focus on the ice terrains that we placed our walls on, because we use different types of ice terrain to get everything to get in this proper place. But since the terrain looks consistent all the way around, we would expect the properties of the terrain to be consistent all the way around also. And that's not necessarily the case here, because if we recall, we placed the gates on top of beach ice instead of normal ice. So if we were to delete the gate, we would be able to rewall parts of it, even though we would not be able to rewall other parts if we, for example, deleted a wall in the back. Since this is not a beach terrain, this is not wallable. So in order to fix that problem, we're going to change the terrain table for walls to make it so they cannot be placed on beach terrains. So we'll do wall class, and we'll put it on the same terrain table as a house. And normal houses cannot be placed on beach, so we'll set that terrain ID to 4. And we will do the same thing with gate class. So if we were to try that again, we can delete the gates here, and we should expect that we would not be able to rewall, and that's exactly the case here. So regardless of whether the walls are broken in the front or in the back, the terrains behave pretty much the same way. So that is looking pretty nice. Then one final thing that we have yet to consider is that we used saleable ice to create the walls around the back and the sides. And if you were paying attention at the beginning, the saleable ice is actually dockable. So even though that looks pretty funny, these kinds of shenanigans aren't really something I want to have in the map. So I'm going to try to change the properties of docks in order to prevent them from being placed on this saleable ice also. So if we take a look at the terrain tables we have available, let's go to dock. Docks are normally placed on water, and for some reason that includes saleable ice. But if we look down here, we can see another terrain table ID, which is 21, which limits it to only shallow water. So if we try that, we can say change the dock to terrain table 21, and we'll see if that fixes our issue. So that prevents the dock from being placed on the ice, and it does not prevent it from being placed on these little pools of water here. Not that that would ever be super useful, but it's a good way to get around this issue without having to disable docks entirely. So that works for Dark Age docks, but keep in mind that if you were to start the game in the Feudal Age, Castle Age, or Imperial Age, the dock building, which is represented by this constant here, is not necessarily the one that's going to be showing up if you were to start the game in a different age. So we can see there's different dock objects here, and these first 4 are representing each one per age. And to cover all our bases, we'll do dock underscore F for the Feudal Age dock, underscore C for the Castle Age dock, underscore I for the Imperial Age dock, and then just to cover our bases even more, harbors are 1189. We'll do the same thing for harbors, so that there's no way to put any sort of blocking thing on a wall after it's been destroyed or deleted. And I think that about does it for everything I wanted to cover in this map. So this is one that required quite a few tricks to be able to get the map the way we wanted, but the end result is quite satisfying, and it looks pretty nice as well. So that's going to be it for me for now. So thanks everybody for watching, and I'll see you next time.